The first thing that we're going to talk about today from section 4.3 will specifically be about evaluating a polynomial given a certain value. All right. So this is, a lot of people have a really hard time when I say the word evaluate, but what I really want you to think about when you hear the word evaluate and then you're given something like a polynomial. So if it said like 5x to the third minus x squared plus 13x plus 29 at x equals 4. There are a lot of people in here that that basically what they're doing is they're trying to find a way to solve this equation with x equals 4. So they'd put a 0 in there, and then they'd plug in 4, and then they'd start to solve random things, and I don't really know what their goal is. But really, when you see something that looks like this, you can just take that 4 and plug it into the equation and figure out what the function is equal to when x is equal to 4. Now, that's something that every single person in here knows how to do. I'm not taking that away from you. But I'm telling you that there is a way that you can do this with synthetic division. And some of you have gotten really, really good at synthetic division, like to the point where you can finish a synthetic division problem in seconds. Now, that's something to just kind of think about, all right? Because I prefer synthetic division when doing these because it just makes my life easier. But you can use synthetic division to actually evaluate this polynomial at x equals 4. The way that you do that is you still write your coefficients down the same way that we did the other day. So 5, -1, 13, 29. So we still have our x to the third term, x squared, x, and our constant, same way that we did before. And then we're going to put our little box right there, and then you're going to put this number on the outside. So remember, it's essentially the exact same thing as what we did in synthetic division. But now the thing is, this number that we get down here in that little spot, that is going to be the answer. So if you are already in the mode of using synthetic division, that number that you get right down here is going to be the answer of what happens when x is equal to 4. All right, that's just the way that it works. Someone found out that that works with synthetic division. If you want to use that method with synthetic division, that's fine. If you would rather just take this 4 and plug it in and solve it that way, you can do that too. It makes absolutely no difference. I prefer to use synthetic division just because it's a little faster and I don't have to rely on my calculator pretty much, right? So I'm going to drop that 5 down. 4 times 5 is 20. -1 plus 20 is 19. 19 times 4 is the same thing as 76. Add those together and I get 89. And then this is the only downfall because I do have to use my calculator for things like this because that number is too big for me to do in my head. So I get 356. And then I'm going to add 29 and I get 385. This is the answer you get when you plug in 4 to that problem. All right. Now it has to do something with the remainder theorem. The fact that the remainder theorem exists, that tells you, or that will help you. We could go through a proof of the remainder theorem, but I'm going to be honest with you, 99% of you don't care. If you do care, then we can talk about that after, and we can actually go through that method and what the remainder theorem actually is. But for the most part, I don't think most of you care, so most of you aren't going to benefit by what you're looking at. All right. So that being said, did I mess something up? I feel like I messed something up. Oh, no, I'm good. Okay. So if you have any questions or issues about this, please make sure that you ask me. But solving or evaluating using these types of ideas, all you are doing is synthetic division. So if I ask you to evaluate something at a value and you just do synthetic division, this thing right here will be what your answer is. It's that easy, that simple. If you already know synthetic division, it's a very simple topic. Okay. If you don't know synthetic division, it might make it a little bit more challenging. Okay. So that being said, I would use synthetic division. Be prepared for some questions that look almost identical to this on your test on Friday, because I'm going to give you 1 or 2 of them because it's a really good way to test whether or not you understand synthetic division. All right. Does anyone have any questions about this part?
Yeah, I have a question.
Go ahead.
So what type of question would this be? Like, would you have to solve for x on this equation? Or
No,
just...
this is not a solve for x. Basically what this is saying is, what does this thing equal when I plug 4 in here, here, and here? What is that red circle equal to when I plug in 4? and that red circle is equal to this number right here.
Okay, cool. I was
So
just
that's what
making,
it's asking.
yeah, we didn't have to do anything else.
Nope, you don't have to do anything else. And that's why this is kind of nice, because it takes all of the work and like hard, multiplication, making sure your calculator has parentheses in there. It takes it out of there. I mean, to each their own though. I mean, if that's something, if you don't want to do this, I don't really have an issue. You just have to understand that when you see something that looks like this, because the question will say, evaluate this at this point using synthetic division. It will ask you to do it that way. And if you understand that all it's asking is plug x equals 4 and what does that mean, then you're good. All right, the last thing I want to talk about today is being able to factor something that looks like this. All right, being able to factor this thing. All right, so you have a couple different jobs, a couple different things that you should be able to do, or a couple different things that you should be looking at. All right, all of these, like this one right here, I think that I might be able to factor that by grouping. Now that's something that we did a while ago in section 4.4. So since we did that in section 4.4, I'm not actually going to go through this. Okay, you should know how to do this. I will post the answer key to this later if you want to look at that. Questions like this are a little bit more challenging. Now, some of you could probably see, well, I can see right here, if I split this in the middle, I see a nothing, -3, and a -4. I see a nothing, a -3, and a -4. I might be able to factor this by grouping. Some of you might see that. That's great. This one right here, you might not be able to see it all because I can't see any sort of factoring by grouping. I can't see any sort of anything that will allow me to solve this question. So since I can't see anything that's going to allow me to solve this question, if I'm asked to factor this, I'm kind of at a loss right now. So since I'm kind of at a loss right now, I have absolutely no idea what I'm going to do in order to help me solve this or to factor this, right? So if I don't know what I'm going to do, my best bet is this thing right here. Plug it into my calculator and see what my factors actually are. Remember, a factor, if you don't remember this, a factor is a solution to the graph, or it is where the graph crosses the x-axis. So it is where the graph crosses the x-axis. So it's a solution to the graph or where the graph crosses. So if you can look at this thing and find where it crosses the x-axis, then you know where some of the factors are. And now the thing is, what I can do using synthetic division is I can take my factors and I can divide this entire thing by factors, because really what factoring is, it is taking something big and factoring something out to make it smaller. It's just like division, right? If I ask you to factor or find the factors of 55, you would find the factors of 55 by pulling out the 5 and 11. The 5 and the 11 are the factors, the things that you multiply together to get this. That's what factoring is. It's the things that you pull out, so that way if you multiplied them all back together, you would get this. That's what we're doing here, all right? That's what we're looking for. We're looking to find what things we can pull out in order to multiply them back together to get this thing right here, all right? So I'm going to show you what I would do here. My first check is I would say, can I factor this by grouping? And I'm not going to be able to factor it by grouping because there's an odd number of terms. 1, 2, 3, 4, 5. I can't use difference of squares. I can't use difference of cubes. I can't use sum of cubes. I can't use the Brooklyn method. I can't factor it like normal. I am at a complete loss for this. I have absolutely no idea how to factor this thing. Since I don't know how to factor it, my first step is going to be to go to some sort of graphing thing. All right, I'm going to graph this somehow. Oops. So what I'm going to do is I'm just going to graph, whether you're using your calculator, whether you're using Desmos, whatever you're using. So I'm going to do 4x to the 4th plus 26x to the 3rd minus 8x squared plus 39x minus 21. So what I'm going to do right now is I notice that I have a nice crossing point, right? I actually have two kind of nice crossing points. But what I'm going to do is I'm going to pick one of those crossing points, and I'm going to use synthetic division, okay? Now, if you want to, you could use synthetic division with this number too. It doesn't make a difference. But right now, based on what I just found, I found that my graph crosses at -7. So I'm going to put here x crosses at -7. And I also know, I might save this for later, we might use this, I don't know, the x also crossed at 1/2. All right, so let me pull that back up so that we can talk about it and look at it again. X crossed at -7, which is what I have there, and x crossed at 1/2. There are two places this thing crosses. I can try to zoom out and see if I can see any more, but I can't, right? It doesn't cross at any other places. So since it doesn't cross at any other places, I can't use any other factors. So what I'm going to do right now is I'm going to use this information to help pull out nasty things out of here, all right? So what I'm going to do is use synthetic division. Now, before I use synthetic division, I want to think about what my factors look like, okay? So I'm going to erase this one for now. We can use that in the future if we wanted to, but I'm not going to use it yet. I'm going to say for sure I have x equals -7. And if I think about that in factored form always goes backwards, and I would have to be able to solve it like this, right? Because factored form, we always take our factored form and set it equal to 0, and then we get our value, our solution. So what I have here is I know that my solution or my factor is going to be x plus 7. So I'm going to go through my synthetic division, and I'm going to divide by this number right here. But in the like at the very end, I'm going to remember that x plus 7 is the factor that I divided. So I'm going to put in my values. So I have 4, 26, -8, 39, and -21. And I'm going to divide by -7. That's this number right here. I'm going to divide by the solution. This thing is the factor that I will use later on. But this thing right here is the number that I'm going to divide by. So now I'm just going to go through and do my synthetic division. Drop my 4, multiply -7 times 4 to get -28. Add these two together to get -2. -7 times -2 is 14. -8 plus 14 is 6. -7 times 6 is -42. 39 plus -42 is -3. -3 times -7 is +21. -21 plus 21 is 0. This will always happen with zeros. So if you found a 0 on your graph, which we did, -7, 0, if we find a 0 on our graph, the remainder will always be 0, no matter what. Because think about it. If I give you a number like 55 and I said divide 55 by 11, 11 is a factor of 55, which means there will be no remainder. If I take this thing and say divide it by a factor, there will be no remainder because we are dividing it by something that goes into it perfectly. Okay, so that's something to kind of think about. So right now, what I've essentially just created is I have essentially just created a new equation. This was x to the third. Now this is, or I'm sorry, this was x to the fourth. Now it is x to the third, x squared, x, and our constant. So I've really just created 4x to the third minus 2x squared plus 6x minus 3. Now this is something we might be able to factor. So now I'm going to go through this and I'm going to factor this. I am going to factor this using grouping. This is something we learned about in section 4.4. So if you're looking at this saying, oh man, I don't know what's going on, this is from section 4.4. So I'm looking at this first part and saying, what can I pull out of each of these terms? Well, I can see that 2 goes into both of them, and I can see that x squared goes into both. So 2x squared can be factored out. Then I'm left with 4x to the third divided by 2x squared will be 2x. 2x squared divided by 2x squared is 1. And then this one, I can see that I can factor a 3 out of this, right? So I can factor a 3 out, and I'm left with 2x minus 1. And now I have successfully factored this by grouping. I'm going to combine these two, and I'm going to leave my parentheses together. So 2x squared plus 3, and then 2x minus 1. And then the thing that I can't forget is this one was in my original problem. So now I have to bring this down into this problem down here. So I'm going to have my x plus 7. I just have to check to see if there's any difference of squares, difference of cubes, or sum of cubes in here, which this is not a perfect square. Neither is this. This is not a perfect cube. Neither is this. So I can't do anything. This is my completely factored form. So you see how we took one step to use synthetic division, in order to be able to factor by grouping. So we did one thing, and then we factored it by grouping. All right. Now that's something that you're going to be able to do every single time. You can type this into your calculator and see where it crosses. So you can see where that thing crosses. If you can find where that thing crosses, you are really, really good to go. If you can't find where that thing crosses, then we might not be able to factor this like normal. But if you remember way, way back to the beginning of the problem, I had said that x equals 1/2 was also one of my factors, right? That's this one right here. This thing right here, when I solve it, is x equals 1/2. So I actually found out that x equals 1/2 in my problem anyway. Okay? So let me pause recording for a second.